15.5, Solving Radical Equations. A radical equation is an equation with a root symbol. We're going to be talking specifically about square roots. And to solve radical equations, we need to follow these steps. The first step is to isolate the square root symbol on the left side of the equation. Then, to undo that square root symbol, we're going to do the inverse operation, which is to square both sides of the equation, and that gets rid of the square root symbol because squaring and square rooting are inverse operations and they undo each other. Then, once we get rid of that square root symbol, we want to isolate the variable and then check our solutions to make sure that our answer is correct. So let's do that in number 1. The first step is to get the radical on one side of the equation, and that's already done. So then we're going to go on to the next step, which is to square both sides to get rid of the radical. So we're going to square both sides of the equation, and like I said, squaring and square rooting are inverse operations, so they just cancel each other out, and I'm left with x equals 5 squared, which is 25. So that's my solution. Let me check my solution by plugging it into the original equation. So if I plug it into the original equation, my answer, I have the square root of 25 equals 5. Well, the square root of 25 is 5, so I know that I have the right answer. Now, in these types of equations, it is important to check your answer because you can get what we call an extraneous solution, which is a solution that doesn't work. All right, so let's try another radical equation. Again, we already have the radical by itself on one side of the equation, so we're going to undo that by squaring both sides. So when I square this square root, it cancels out and I'm left with 2x minus 3 equals 5 squared, which is 25. Okay, so this is a linear equation, and I'm just going to solve it by getting x by itself. So I'm going to add 3 to both sides, and I get 2x equals 28, and then I divide both sides by 2. So I get x equals 14. Okay, so let me see if that is correct. So to do that, I'm going to plug 14 in to my original equation. I have 2 times 14 minus 3 equals 5. Okay, it doesn't look like a 14. All right, so 2 times 14, that's 28 minus 3. 28 minus 3 is 25, and the square root of 25 is 5. So this answer is correct. All right, in number 3, the radical's by itself, so we're going to do the next step, which is to square both sides of the equation. When I square the square root, it cancels, and I get x equals negative 5 squared would be positive 25. Okay, so that's my solution. Let me check it. If I plug 25 into my equation where the x is, I have the square root of 25 equals negative 5. Well, the square root of 25 is 5, and 5 does not equal negative 5. So there is no solution to this equation. All right, let's try another one. Here in number 4, the radical is not by itself. We have this minus 3 that's on the same side of the equation as the radical. So we need to get rid of it first, and we'll do that by adding 3 to both sides of the equation. So that gives me the square root of 6x plus 4 equals 8. Now that I have the radical by itself, I can square both sides of the equation. When I square the square root, it cancels out. And 8 squared would be 64. All right, so now I'm going to get the x by itself. I'm going to subtract 4 from both sides. And I get 6x equals 60. Divide both sides by 6. And x equals 10. All right, so let me check that. If I plug 10 into my original equation for x, I have the square root of 6 times 10 is 60, and then 60 plus 4 would be 64. Well, the square root of 64 is 8. And 8 minus 3 is 5. So 10 is my solution. All right, in number 5, the radical is by itself. So I'm going to square both sides of the equation. Now, when I square the square root cancels out, but on the other side of the equation, I have a binomial now that's being squared. So remember, when we square a binomial, we don't distribute that square. This is stuck together, and it means this binomial times itself. So I have to FOIL that. All right, so I get x plus 5 equals, that would be x squared minus 1x minus 1x plus 1. All right, so now I am going to combine my like terms. That gives me x squared minus 2x plus 1. And now I see that I have a quadratic equation. So a quadratic equation is one where we have the highest power is squared. It's not linear, so we can't just get x by itself. We have to solve it like we would a quadratic equation. So remember, in quadratic equations, we can solve those by factoring, the square root method, or the quadratic formula. Factoring is easiest, so let's see if we can factor this equation. And to factor, we need to move everything over to one side of the equation. So I'm going to move over the x, and I get 5 is equal to x squared minus 3x plus 1, and move the 5. All right, so that gives me 0 is equal to x squared minus 3x minus 4. All right, let's see if this will factor. This is a trinomial. Trinomials factor into two binomials. X squared would the things that would multiply to give me x squared would be x and x. This sign tells me that my signs are going to be different. And so I need the factors of 4 that would subtract to give me 3, which would be 4 and 1. And then this tells me the sign of the bigger number. So 4 would go here and 1 would go here. So if you'll remember, the way that we check our factors to make sure that we factored it correctly is by doing our smiley face. So I would do, this is 1x, and this is negative 4x, which gives me negative 3x. And that's what I needed it to be. So I see that it factored correctly. So now that I know that I've factored correctly, I take each factor and set it equal to 0 and solve. So I'm going to have two solutions here since this is a quadratic. All right, so I take x plus 1 and set it equal to 0, and x minus 4 and set it equal to 0. All right, so this would give me x equals negative 1, and this gives me x equals positive 4. All right, so I need to check these solutions. by plugging them each back into the original equation. All right, so if I plug -1 back into the original equation, let me see what the original equation was. Okay, so I would plug this into, so it's x plus 5, so that would be -1. One second. Okay, that would be -1 plus 5 equals -1 minus 1. All right, so -1 plus 5 would be 4. And -1 minus 1 would be -2. Well, the square root of 4 is 2, not -2. So this is an extraneous solution. All right, let's try 4. When I plug that in, 4 plus 5 equals 4 minus 1. All right, well, 4 plus 5 is 9. 4 minus 1 is 3. And the square root of 9 is 3. So 4 is my solution to the equation. And that's how we solve radical equations.